Download this code from codegive.com, link in the description below. Handling null parameters with reflection in Java. Reflection in Java allows you to inspect and manipulate classes and objects at runtime. This is powerful, but it also introduces complexities, especially when dealing with method parameters. One common challenge is handling null values gracefully when invoking methods reflectively. Incorrect handling can lead to null pointer exceptions or unexpected behavior. This tutorial provides a comprehensive guide to address this effectively. Understanding the problem. When using reflection to invoke a method, you typically use method.invoke. This method takes an array of objects as arguments. If your method expects a non-null parameter, and you pass null via reflection, the behavior depends on the method's implementation. The method explicitly checks for null. It might handle the null gracefully, perhaps throwing a custom exception or returning a default value. The method doesn't check for null. A null pointer exception will likely occur inside the method itself. The method uses the null parameter directly. The method might function correctly with a null parameter, using it as a signal, example to skip an operation. The key is to anticipate the method's expectations and provide appropriate parameters during reflection invocation. Strategies for handling null parameters. 1. Explicit null checks before invocation. The simplest and safest approach is to check for null values before calling method.invoke. 2. Using optional parameters, Java 8+. If you have control over the method's signature, using java.utility optional can improve the design and make null handling more explicit. 3. Wrapper classes. Primitive types in Java cannot be null. When you work with reflection and expect primitive types, you should always use their corresponding wrapper classes, example integer, boolean, double. Wrapper classes can be null. 4. Default values based on parameter type. You can programmatically determine a default value based on the parameter type. Important considerations. Error handling. Always wrap method.invoke in a try-catch block to handle potential invocation target exception, illegal access exception, and illegal argument exception. These exceptions can reveal issues with parameter types or method accessibility. Parameter types. Ensure that the objects in the params array are of the correct types expected by the method. Type mismatch leads to illegal argument exception. Method accessibility. The method you're invoking must be accessible, public, or accessible through reflection. If it's not, you'll get an illegal access exception. Checked exceptions. If the method throws checked exceptions, your try-catch block needs to handle those as well. This detailed tutorial provides a foundation for handling null parameters effectively when using Java reflection. Choosing the best strategy depends on your specific needs and context, emphasizing safe and robust code. Always prioritize explicit null checks and proper error handling to prevent runtime surprises. Remember to adapt the default value handling to the specific types used in your methods.